Okay, going through this A-level chemistry question. This one is about the elements in group two, part of your A-level spec. So let's get into it. 2.1, explain why the third ionization energy of beryllium is much higher than the second ionization energy of beryllium, and it's worth 3 marks. So what we want to do is look up on the periodic table and find out beryllium's atomic number so that we can work out its electronic structure. So beryllium just has 4 protons, therefore equal to the number of electrons, 4 electrons. So we got one s2 and two s2. Now that's great when we do it like that, but when we show the box orbitals, we can really get into what is going on. So I'm going to show those arrows and which each one represents an electron. Of course, they're spinning in opposite directions, hence one arrow up, one arrow down. That minimizes repulsion. So for the first ionization energy, I want to take away one of these electrons, right? So boom, taking that away. That's the first ionization energy. You're breaking into a brand new orbital, a completely filled orbital. Um, and here we go. So that requires quite a bit of energy. Now, the second electron doesn't require so much energy. Guess what? You're taking an electron from a partially filled orbital. So it's a little bit easier to remove an electron from a partially filled orbital. So we're going to zing that one out. And that was for the second ionization energy. Okay. The second IE. Now look at the third IE. Now for the third IE, what are we doing? Well, couple of things we need to know. We're breaking into a brand new energy level, and that's represented by one. We're breaking into the first quantum level or shell or energy level. So that requires more energy when you break into a new energy level. So that's the main marking point. We're breaking into a new energy level. But what is it about that energy level? Well, that energy level is closer to the nucleus, and so feels the electrons in it feel a stronger attraction. Also, it's a completely filled orbital, so it's more stable. And also, there's no shielding. Look, there's no shielding here between the nucleus and these electrons. Whereas when we were removing these electrons, i.e., we were taking out the one for the second and the one for the first, these bad boys, they had the shielding between them and the nucleus of the first energy level. So we want to put all that down to get the mark. So the three main points are um, breaking into a new energy level, okay, which is closer to the nucleus. Now there isn't, so it's closer to the nucleus. Uh, so ooh, the electrons are um, attracted more strongly, or they feel the the stronger attraction. Whatever. We've expressed that, even though I can't spell or type. Attract, attracted. There we go, or whatever. Okay, so that's like 2 marks. We're breaking into a new energy level. It's closer to the nucleus, more strongly attracted. The other things I want to cover are I want to say, well, there's less shielding. Um, so that's going to get me a mark as well. The fact that there's less shielding. Now we've removed that second energy level. No, you might want to actually say, if you want to, I've left myself not a lot of room. I'd probably say when you're doing the second ionization energy, you're removing the electron from the second energy level. It's a partially filled orbital, and it has shielding. Whereas when you're taking an electron, the third ionization energy is removing an electron from a brand new shell that's closer to the nucleus, complete orbital, which is more stable, and there's less shielding. And as it's closest to the nucleus, more attraction, basically. So all of that, what I've said, I would whack in there as well. Kind of run out of room there with my explanation, but here we go. I'd put the whole lot down. That way you're guaranteed to get the 3 marks. If it's 3 points, I wouldn't just put 3 things down. I'd always try to put 4 or 5 things down, as long as they're correct scientifically. Okay. 2.2. Magnesium reacts slowly with cold water, but rapidly with steam. Compare these reactions in terms of the products formed. You should identify one similarity and one difference between these reactions, and that's worth 2 marks. So you really have to know these reactions off by heart. If you don't know them off by heart, what are you doing? Get them on a revision card and memorize those. You can be just chilling out. Revision cards aren't perfect. You're not going to get an A star from revision cards alone, but these kind of revision tips, these are going to supplement your overall package. So if it's things like learning your group 2 equations, the best way to do that is to smash them onto a revision card and learn them like that. So we got like magnesium, when yeah, it's solid at room temperature, isn't it? If we add it to water when water is in the liquid phase, and you need to know this off by heart, guys. Just like all or most metal reactions with water, when we're looking at group 1 and group 2, and you did this in GCSE, you're going to make a metal hydroxide. Obviously, it's group 2, so there's going to be 2 hydroxide ions with it. Because each one of those is -1 and magnesium's group 2, so we'll be +2. And then what we're going to do, we're going to form hydrogen gas. You remember this from your alkali metal content in GCSE. And this is going to be AQ. Although magnesium hydroxide is only sparingly soluble, we can put AQ there as some of it will dissolve. Now, it's not completely insoluble, magnesium hydroxide. So we've got magnesium plus water makes magnesium hydroxide and hydrogen gas. So let's have a look at what we make when it's with steam. So we're going to have magnesium solid plus water. The only thing you want to change here in the reactants is that the water must have a G next to it. Just spotted that's not balanced because I've got 2 hydroxides there, so I need 2 waters. Yeah, that's all balanced. Okay, so I'm going to do water, going to smash across. This time it doesn't make magnesium hydroxide, it makes magnesium oxide. You're going to see a white solid there. That's going to be insoluble, and it's going to produce hydrogen gas as well, which I'm running out of room. So we can spot here straight away, and that's balanced, that one, isn't it? Yeah, 1O, 2H's, 2H's, 1O. Yeah. That's completely balanced. Right, let's spot the similarity. Check it out. Okay, so let's put that similarity down. Both reactions release hydrogen gas. Now, imagine this question is just asking you to compare them and say what the difference is, what the similarities and the differences. Now, you could get one that's talking about observational similarities and observational differences, and this didn't. But if it was observational similarities, we could say, oh, you'd see bubbles in that one, or squeaky pop test, or whatever, some identifying feature of the hydrogen gas. Now, with the difference, you can see the difference as well. Let me just highlight that. Okay, let's highlight the difference. This one makes magnesium hydroxide solution, and this one makes magnesium oxide solid. So again, observationally, both magnesium hydroxide when solid and magnesium oxide are going to be white because they're group 1, 2, or 3 compounds, which are all white because they're not transition metals. However, you're going to see a larger amount of white solid with the magnesium oxide formation, whereas you've got water with the magnesium hydroxide forming a little bit of a colorless solution, as well as probably some white solid being seen there as well. Right, what's the main difference? All we have to do is say the difference here. The observations are quite difficult, so we're just going to say magnesium hydroxide. You don't have to do the formula. You could just write it formed with water, but with steam. MgO, magnesium oxide, is formed instead. Bosh. And that's going to get you the 2 marks there. All right, let me zing down, zing down, zing down, zing down. So zoom in a little bit. I've still got a cold. I've had this cold for weeks. 2.3, the reaction of calcium with water is a redox reaction. Explain in terms of oxidation states why this reaction involves both oxidation and reduction. So what we want to do here, guys, we want to write this one out. So this is typical. It's just a group 2 hydroxide reaction. This should be dead simple for you guys because you probably know your group 1 ones from GCSE. So H2O, which is a liquid, it's going to form calcium hydroxide like this. That's going to be aqueous-ish. You know, it's not, none of these are 100% soluble, but there we go. We're going to get hydrogen gas. So we just balance that up. We've got 2 H's there, 2 H's there. Oh, but I've got 2 H's there as well. So I need 2 of these and I've got 2 O's. That's all balanced. We just need the 2 there. Okay, so let's look at why this is a redox reaction. So you should know how to do this. Calcium is in its elemental state, so it has a 0 oxidation state. If we take that through to here, calcium is now in a +2 state because it's a group 2 metal, and that means what has happened to it? It has lost 2 electrons. And what has happened if you've lost 2 electrons? Do you remember the little funky thing, oil rig? You probably learned that at GCSE as well. Oxidation is loss. So the calcium has been oxidized. So we can say, oh my days, check this out. Calcium has been oxidized. It lost 2 electrons. It got oxidized to calcium ions in the calcium hydroxide, and that's going to get us a mark. And then I also want to explain why there's reduction. We'll check out the hydrogen. The hydrogen has an oxidation state of +1. How do I know that? Oxygen is always -2, and there's two H's, and each one must be +1 to balance that -2 oxygen. Anywho, hydrogen is +1 there. But when you take hydrogen over here, hydrogen is now in its 0 oxidation state. It doesn't have any ionic charge when it's in its elemental form. So what has happened? It's gone from +1 to 0. So H gained, oh my days, H gained an electron. What's gain of electrons? You know what the gain of electrons is, right? It's reduction. Reduction is gain. So we want to say hydrogen has been reduced. It gained an electron. Now, if we really want to get funky with it and over explain it, we can say it went from a +1 oxidation state, but the more I type, the more errors I make, to a 0 oxidation state in elemental form. Okay, so from K, what the hell? There we go. I could have said the same wiffle waffle for that. I mean, you'll probably just get it for saying calcium has been oxidized, lost 2 electrons. But you could say calcium goes from 0 to +2, meaning it's lost 2 electrons, if you really wanted to get funky. And that's the end of the question. Don't forget sharing's caring. Hit the like, punch up the bell, subscribe. Let's get to the marks.
You're still here? It's over.